Okay, 10-76, intersecting chords. Timothy asks, what if two chords intersect inside a circle? Can triangles help me learn something about these chords? So we're going to create triangles in here. You can see the two chords A, B all the way across and D, C all the way across. Timothy decided to create two triangles, triangle BED and triangle CEA. My line tool here and create some triangles. So BED would be, we'd have to connect B to D to create triangle BED. And then we would also connect point C to point A to create a smaller triangle CEA. All right, now in part B, it says compare angle B and angle C. So in order to do that, we need to think about the chord that, or the angle formed and then the arc it's related to. So angle B is created by this segment here, by D, oh my goodness, by DB and by EB. So this right here, oh, let's go all the way from A. There's our angle B. And when we think about the arc it intersects arc DA. And then if we look at angle C and which sides create angle C, these two sides, you can see that angle C also intersects the same arc. They have the same arc in common. And because they are inscribed angles that intersect the same arc, that means that they will be congruent to each other. So these are equal angles. And then, all right, so to answer our question for part B, which is larger, how can you tell? They are not larger. So angle B and angle C are congruent. Because they intersect the same arc. And now we want to do the same type of comparison with angle D and angle A. So you see this, we're going to compare angle D with angle A. So look at the sides that create angle D. So we have angle D right here. And then angle A over here. And you can see that angle D and angle A both intersect this arc. And because they share the same arc, they will also be equal to each other. All right, so for the same reason. Okay. All right, so now that we have that established, part C says, how are triangle BED and triangle CEA related? And because they have these angles in common, we can definitively say that the two triangles are congruent. Or sorry, not congruent. Wow, they are similar. Oh my goodness, sorry. The triangles are similar by angle similarity. So remember that rule, when we have two angles in common, then the two triangles are similar. So the triangles are similar by angle. No, the triangle BED is bigger, but they're the same shape. All right, now the last question says, if segment DE is 8, all right, so let's go ahead and add in this information. A segment DE is 8, and segment AE is 4. And segment EB is 6. What is segment EC? So this is our unknown, our X, our unknown. Okay, so we're trying to find C. So the deal with this is that we have similar triangles. So what that means is we have proportional sides. So at this point, what we can do is set up a proportion between these values. So we can say that 8 relates to 4 the way that 6 relates to X, or 8 relates to 6 the way that 4 relates to X. There's multiple ways we can set this up. So I'm going to go ahead and go, all right, I know that 8 is to 4 as 6 is to X. And at this point, I can cross multiply. Ooh, it's messy. All right, so 8 times X is equal to 4 times 6, which means 8X equals 24. And divide out the 8, and we get X equals 3. So I could put a 3 up here now. So what I have here now is all of the sides of these two triangles, like worked out, and they are proportional to each other. All right, so EC equals 3. So in general, there's an actual rule that relates the sections of the two intersecting chords of a circle. So you can see here, we've got these proportions set up for us. We can see that segment A relates to segment D in the same ratio as segment C relating to segment B. So this is where the proportions are set up here on the right. And then if we cross multiply, you can see that A times B will be equal to C times D. And this right here is a rule that can be used. Both are a rule, like both the proportions and this equation here are rules that you can use in order to find missing lengths on chords in a circle.